Hi guys, welcome to Vedanta Education. Today I have one more question from GATE 2014 Electronics and Communication. Here is the question. Assume that a plane wave in air with an electric field E is incident on a non-magnetic dielectric slab of relative permittivity 3, which covers the region Z equal to 0. The angle of transmission in the dielectric slab is. So, we have they have given the equation of the electric field. So, E is given as 10 cos omega t minus 3x minus root 3 z ay volt per meter. Now, if we compare it with the standard electric field equation, so E is equal to E naught e raised to minus j beta r. So, we know that the vector beta r is given as 3x plus root 3 z. Now, r can be given as x ax plus z az plus y ay, where all the a's are unit vectors, and from this we know that beta here is 3 ax plus root 3 az. So, we y is probably 0 because otherwise there would be a y term here. So, let us just write that down so that it is not confusing. It is a 0 ay cap. Now, looking at this vectors beta and r, let us just draw this schematic. So, what we have is the axis, and so the beta is traveling in the plane x and z. So, let us just assume that this plane represents x and z. So, let us say this is z axis and this is x axis. So, the best thing to the first thing which is quite important is to fix the axis accurately in order to get the right answer. And in this case, since beta is given by x and z, we will have this plane as x and z. In case if it was ay was also involved, maybe instead of x we could have assumed z and y as this plane, but in this case since ax and az are given, let us just assume that the plane is x and z and y is coming out of this plane. So, let us just draw this vector beta here. So, the vector beta is 3 ax plus root 3 az. So, it is traveling in a positive x and positive z directions. So, this is positive z and this is positive x direction. So, the wave is traveling in positive x and positive z direction. So, it is traveling something like this, and we know that this is beta. So, so the value here is 3 and here it is root 3. So, it is same as root 3. Now, and let us just draw a normal to this surface here. Okay. Now, we know that for z greater than 0, this medium is covered by a dielectric. So, for z greater than 0, so this region is covered by a dielectric slab of relative permittivity 3. Okay. And let us just say this is the transmitted angle, this is the transmitted wave, and we know that this is the incident angle and this is the transmitted angle. So, the incident angle theta I is given as tan inverse of 3 by root 3. So, that means theta I is 60 degree. So, from at this point at the interface, let us just apply the Snell's formula. So, the Snell's formula for refraction, Snell's formula is given as Ni sine theta I equal to nt sine theta t. So, from this, if we apply the Snell formula here, so Ni is this is coming from the free space, so Ni is just 1, and sine of 60 is equal to Nt is given as square root of epsilon r of this dielectric slab, and sine theta t. So, sine theta t is equal to sine of 60 divided by root 3, which is root 3 by root 3 into 2, which is just 1 by 2. So, since sine theta t is 1 by 2, so theta t is given as 30 degrees. So, the angle of transmission in the dielectric slab is 30 degrees. Thanks for watching. Please check out other videos in the playlist that also solve previous GATE questions on electromagnetic theory, and also check out the description where I recommend some books for studying electromagnetic theory for GATE. And if you want to solve more such problems, please go ahead and subscribe to our channel.